The question number 8 is w of x comma y is equal to x plus y plus sine of xy. Then I want to prove that dou square w by dou y dou x is equal to dou square w by dou x dou y. This is a function given. This w is a function given in terms of x and y. So here we are given xy, here we are given sine of xy. I want to prove this thing. So I said already in my previous video, dou square w by dou y dou x is nothing but I want to differentiate with respect to x partially. That answer you want to again differentiate partially with respect to y. So first you want to do the inner term and then outer term. Here you want to differentiate with respect to y partially first. In that answer you want to differentiate partially with respect to x. So this is a thing I want to prove. So now first whatever it is you need to find out dou w by dou x. So dou by dou x of xy plus sin xy is equal to, so this one I want to differentiate with respect to x partially. So if I am doing with respect to x partially, this x will be 1 and I will get y only because y should be treated as constant, plus sine of xy. So I want to consider this is sin x. So what is the differentiation of sin x? Cos x. So cos of xy. I have considered this is x, but this is not x. This is other than x. So that must be also differentiated partially with respect to x, and it should be written as a product. It should be written as a product. So that this will be y plus y cos xy. This is dou w by dou x. Now dou w by dou y is equal to dou by dou y of xy plus sin xy. So this term I want to differentiate with respect to y partially. So if I differentiate with respect to y partially, this y will become 1. This will be x plus cos xy. Sin of xy is cos xy. The differentiation of xy is x. So dou w by dou y is equal to x plus x cos xy. Cos xy. So we have to prove that dou square w by dou y dou x is equal to dou square w by dou x dou y. I told already dou square w by dou y dou x is equal to dou by dou y of dou w by dou x. That is dou by dou y of this answer. Dou w by dou x answer is y plus y cos of xy. So this answer I want to differentiate partially with respect to y. This answer I want to do differentiation partially with respect to y. So differentiation of y is 1. And this I must use as UV method. Because here also I have y and here also I have y. So I must treat as UV. This must be u and this must be v. So here 1 plus first term y I am keeping as it is. Second term is cos xy. So the differentiation of cos xy is minus sin xy. So that inner term xy must be differentiated partially with respect to y. So if I am differentiating xy with respect to partially y, then I will get only x. Because x must be treated as constant, it should be written as it is. Plus the second function we want to keep as it is, that is cos xy. The differentiation of y with respect to y is 1. So I have written like this 1. This minus I am going to bring here, x into y xy sin xy plus cos xy. So this will be the first equation. Now I want to find dou square w by dou x dou y. This is nothing but dou by dou x of dou w by dou y. Dou by dou x of dou w by dou y is nothing but x plus x into cos xy. X plus x into cos xy. So I want to do the differentiation with respect to x partially here. So the differentiation of x is nothing but 1 plus this is x, and here also we have x. So this both must be treated as uv. So first function I want to keep as it is. Second function I want to do differentiation, that is cos x. Cos x means minus sin xy. So this inner term must be differentiated with respect to x. So xy we have, if you differentiate with respect to x partially, you will get y plus the second term you want to keep as it is, cos xy. First term you want to do the differentiation, so 1. Differentiation of x with respect to x will be 1. So 1, this minus I am bringing here, so xy minus xy sin xy plus cos xy. Just look at the first equation, 1 minus xy sin xy plus cos xy. Here 1 minus xy sin xy cos xy. So from first equation and second equation, we can conclude that dou square w by dou x dou y is equal to dou square w by dou y dou x.